In this video, we are going to solve the given trigonometric equation. And we are solving this for theta. And theta is between 0 and 360 degrees. Okay, so the first thing we can do here, we can do the following. We can let beta be equal to 2 theta minus 5 degrees. So when we do that, that of course implies that cos beta, so in place of 2 theta minus 5 degrees, we put beta. So cos beta is equal to a half. So now we go ahead and we solve this. Solve this for beta. And when we solve for beta, through solving for beta, we are going to get the solution for theta. So let's go ahead and solve this. Now the cos beta is equal to half. To get the full solution of this equation, we have to go to our quadrants, our trigonometric quadrants, right? So let's just draw a rough plane here, just to remind ourselves which quadrants is cos positive in. So we draw our plane here, so we can just remind ourselves which quadrants is the cos function positive in, because what we have here is a positive ratio, right? We've got cos beta is equal to a half. It's a positive half. So where or on which quadrants is the cos function positive? We know that the cos function is positive in the first quadrant, because we know that. We can first write this down first. Let's write this down. In the first quadrant, we know that all of them, meaning all trigonometric functions or ratios, are positive here. And then in the second quadrant, we know that sine is positive there. In the third quadrant, tan is positive here. And in the fourth quadrant, cos is positive here. You see, so now our equation, we can see that cos is positive. So now we know for sure, by looking at our quadrant here, that the cos function is positive in the first quadrant and also in the fourth quadrant, rather. Okay, so cos is positive in the first quadrant and also in the fourth quadrant. Okay, so these over here are just rough triangles, and they are right angle triangles, just to guide us when solving. So we know for sure that the solutions of this equation, they lie in the first quadrant and also in the fourth quadrant. So our first solution will lie here, and our second solution will lie over here. Okay, we know this, right? So now to get the first solution, we can use the inverse cos function. Okay, so let's go ahead and do that. So we have the following. We have cos beta is equal to half. So we solve that using the inverse cos function. So we say, therefore, beta is equal to the inverse cos function of half. Okay, so we basically apply the inverse cos function to this side and to this side, and we get this. Now this is going to give us the first solution, which is in the first quadrant. So let's go ahead and solve for that. So we go ahead and solve this in our calculators. We plug in cos inverse of half, and that gives us the following. So this gives us 60 degrees. So obviously that's in the first quadrant. So this over here will be 60 degrees over here. Okay. And to get the second solution, which we know is in the fourth quadrant, we simply use we simply use the following. Again, just to remind ourselves of how this works, okay, we know the following. Obviously, in the first quadrant, we have our reference angle. In the second quadrant, we have, and in this case, since we're solving for beta, we can call it beta, okay? So in the first quadrant, we have the reference angle, in this case, our first solution, which is beta. And in the second quadrant, we're going to have 180 degrees minus beta. In the third quadrant, we've got 180 degrees plus beta. And in the fourth quadrant, we have 360 degrees minus beta. So meaning that to get the second solution, we need to use the following. We need to use this over here because our second solution is in the fourth quadrant. So to obtain the second solution, we have to go 360 degrees minus our initial solution, which is 60 degrees. You see? So therefore, let's go ahead and do that. So we say therefore, the second solution, or we can say or. Let's say or. So the first solution we have it's 60 degrees. That's the first solution. And then for the second solution, we say or beta is equal to 360 degrees minus 60 degrees. Okay? So we go 360 minus 60. And that gives us 300. That gives us 300 degrees. Okay? So now we have our solutions of this equation. We have the two solutions. So this equation has two solutions. And our two solutions are 60 degrees and 300 degrees. Okay? But then, obviously, we can generalize this because the cos function is a periodic function. So we could generalize these solutions. But we do not do that because our initial problem that we were given said that we have to solve for angles between 0 and 360. So we don't have to generalize it. We have to solve for angles between 0 and 360. That was basically the condition of our problem that we were given. Okay? So, meaning that we leave it here. All right? We say we've got two solutions. We've got beta is equal to 60 degrees. And we've got beta is equal to 300 degrees. Okay? So these are our two solutions. But then we were asked to solve for theta. The problem said solve this equation for theta between 0 and 360. So we have to find theta. And remember we said let beta be equal to 2 theta minus 5 degrees. So we've solved for beta. We have found the solution for beta. Two solutions, the 60 degrees and the 300 and the 300 degrees. So that's the two solutions for beta. So now we go ahead and we solve for theta. So we say therefore, now we go ahead and solve for theta. We say therefore, we know that beta is equal to 2 theta minus 5 degrees. Okay, so we substitute that 2 theta minus 5 degrees back there. We replace it. We replace beta with the 2 theta minus 5 degrees because that's what we said beta is. So let's replace it. So we say 2 theta minus 5 degrees is equal to 60 degrees. We start there. We start with the first solution. And this implies that 2 theta is equal to 60 degrees plus 5 degrees. So which implies now we're going to divide both sides by 2. And we end up with theta is equal to 32.5 degrees. Theta is equal to 32.5 degrees. So that's the first solution. As you can see, this is the first value of theta, okay, in our solution. So it's 32.5 degrees or 2 2 theta minus 5 degrees, that's beta again, is equal to 300 degrees. So 2 theta minus 5 degrees is equal to 300 degrees, right? Now, this implies the following. It implies that 2 theta is equal to 305 degrees. So we add both sides by 5 degrees, so we get 2 theta is equal to 305 degrees. And we go ahead, we divide both sides by 2, and that gives us theta is equal to 152.5 degrees. So these are the two solutions of theta that we get. And we don't generalize this. Okay, so that's the first solution, 32.5 degrees. That's our first solution. Second solution is 152.5 degrees. And both of these solutions, they lie within that interval. Okay, they lie between 0 and 360. And so we leave it there. We do not generalize this, so there's no need to generalize this because we're given a specific interval. We're told that find solutions between 0 and 360. And both of these solutions are between 0 and 360. So therefore, we leave it there.